Today we are going to perform our first physics practical, that is resonance tube. Now in this experiment we have to determine the speed of sound in air at room temperature using a resonating tube. Now the apparatus required to perform this experiment are a set of tuning forks, retort stand, a plastic jar, resonance tube, meter scale, vernier caliper and 2 rubber pads. Here we will move to the next part of the experiment, that is to find the inner diameter of this resonating tube using vernier caliper. I hope you all remember the vernier caliper experiment which we have done in 11th standard. So in short I will explain you how to measure the inner diameter of the tube. Now this is the vernier caliper. This is the lower jaw of the vernier caliper. This is the upper jaw of the vernier caliper. Now we will adjust the upper jaw of the vernier caliper into the inner walls of the resonating tube like this. Observe carefully. Can you see this? Then we will note down the MSR, that is main scale reading, or VSD, that is vernier scale division. Now how to see the main scale reading? Now you can see here the first line of the vernier scale division overlaps at 5.4. Can you see this? Now our main scale reading is 5.4. Can you see this? And vernier scale division is 1. Now we have to repeat this procedure thrice from different sides of the wall so that we will get the mean diameter from the 3 different readings. Now I will again adjust this upper jaw of the vernier caliper into the resonance tube like this. Okay. Now we will check the MSR and VSD. Can you see this? The MSR is 5.4 and the VSD is 4. The first, second, third and fourth division is overlapping with the main scale. So that is the VSD. Can you see? The MSR is 5.4 and the VSD is 4. Now we will move to the observation part, that is determination of least count of vernier caliper. So these things we have already learned in detail last year. Now I will just show you what to write in observation part. The first is smallest division on the main scale, x is equals to 0.1 centimeter. Second is total number of divisions of vernier caliper, y is equals to 10 divisions. The third is least count of vernier caliper, that is x upon y is equals to 0.01. The fourth is zero error. Since there was no error in our instrument, so the zero error will be dash. Zero error correction is dash. Second part is and correction is given, e is equals to 0.3 is equals to 1.675 centimeter and the room temperature is 30 degrees Celsius. Now we come to the next part, observation table for inner diameter. Observation number 1. Main scale reading first is 5.1, 5.5, for that VSD is 1. Then VSR, that is B into LC. What is the value of B? 1. And the LC is 0.01. So the answer is 0.01. Now next, diameter A plus B into LC. A is 5.5 plus B into LC is 0.01. So the final answer is 5.51. Now the observation number second, MSR is 5.4. For that the VSD is 4. Next VSR, that is B into LC, is B is 4, LC is 0.01. So the answer is 0.04. Now next diameter, the value of A is 5.4 plus the value of B into LC is 0.04. The answer will be 5.44. Now the third one is MSR is 5.7. For that the VSD is 1. Now VSR B into LC, the value of B is 1. The value of LC is 0.01. So the answer is 0.01. Now the diameter, A is 5.7 plus B into LC is 0.01. So the answer is 5.71. Now next final is mean diameter. How to calculate the mean? You have to add the 5.51, 5.544, 5.44, 5.71, add the three values and divided by 3. You will get the mean diameter, that is 5.55. Now we will move to the next part, procedure. Here the set of tuning forks, 2 rubber pads, a plastic jar filled with 85% of water, resonance tube, retort stand and meter scale. Observe the setup carefully. Now first we will put this rubber pad into the plastic jar for safety of the jar. Now the second step, we will fix the resonance tube vertically in the plastic jar with the help of this retort stand. See how to fix it in the plastic jar with the help of stand. Observe carefully. You have to fix this jar like this. Now we will choose the tuning fork of frequency 256. This is the tuning fork of frequency 256. Okay. Now we will strike the tuning fork gently on the rubber pad, so the prongs start vibrating. You cannot see the vibrations in the camera. Now again I will show you. I will strike it gently. Prongs start vibrating. Immediately I will hold the tuning fork just above the open end of the resonance tube. See carefully. You have to place the prongs like this. Here the prong should not touch the resonance tube. Now we will adjust the height of the resonance tube till the loud sound is heard. Now I am showing you striking the prongs. Now we will clamp the tube in which loudness of the sound produced. Now we will measure the length of the air column in the tube from the water surface to the open end of the resonance tube. You have to place the meter scale like this. Now we will measure the length of the air column from the water surface to the open end of the resonance tube. So you have to place the meter scale like this, and we will measure the length of the air column. So what is the length of the air column till the open end of the resonance tube? I think it is 29, no? Yes. The length of the air column is 29. So we will note. Now we will repeat the procedure with other tuning forks in the increasing order of frequencies. Now we will find that length increases as the frequency of tuning fork decreases.